couple of news links you might like. There's a couple Microsoft Azure training days, free from Microsoft. So you might want to go to some of these and learn about databases in Azure. You can sign up. One is March 18 and 19, and the other is March, I think, 30 and 31. Yeah, so on my news links, you can sign up for those if you like. That's worth extra credit. Any kind of extra training outside class like this is worth extra credit. This is an interesting Twitter thread from this person, Julie Carey Wong, who is a reporter, and she talks about how, I've heard this a lot from people, mostly women, that if you are a reporter and you touch anything political, you get harassed on Twitter until you just give up and quit. I know quite a few women have abandoned social media for this. And so she reported on 8chan and white nationalists, and so then got completely harassed online. They harass you, they find your home, they scare your family. And then she said you changed what she covers after that, changes what she says, which is, of course, the goal. They scare you into not reporting on that stuff anymore. So I think it's important that this kind of information gets out there for anybody that doesn't understand it. The amount of online harassment, which is partly just fanatics and partly bots and paid attackers to suppress and distort online news reporting, is very large. So China and Russia are going to launch a space station. I guess competition for the ISS. It's going to be a few years before it goes up, and they're talking about it, so this is interesting. I know 3 nations just sent probes to Mars. One of them was United Arab Emirates. I think it was the United States and China all sent probes there at the same time. So a lot of nations are going into space. So it's interesting to see. I think China just went around the dark side of the moon, and so, you know, there are a lot of nations back in space now. This is pretty incredible. Watch what this guy does with this drone. Flies it into this bowling alley and down by the pins and right over the people. They're really, really going close to things. It's an amazing bit of drone flying. We have a little cheap drone that I won at a conference, and that thing is hard to fly, hard to steer. That's not easy to do that, what he just did, go through that little hole. Anyway, that's a pretty amazing shot. I had to take down my bird feeder. There is some kind of disease that is killing the birds, and they get infected when they cluster at the bird feeder. So I took down my bird feeder, and all the birds come up and stare at me saying, where'd it go? But anyway, they say you've got to take it down for like 2 or 3 weeks. Well, it might be a rich person's hobby. The one I got was free, and I guess even if you buy it, it's pretty cheap, but it isn't very good. So yes, I think you probably would need a much better drone than the one I have to do a shot like that. I never got any good at it at all. Student practiced with it a lot until I got pretty good with it, but couldn't do anything like that. So the Linux Foundation wants to start signing their software, which is an interesting idea. I'm not sure how this will work. Like I mentioned, I got a code signing certificate recently, and the whole point of a code signing certificate is you have to pay an expensive cost, and you have to be sort of audited as a company, because the company that sells you the certificate is basically adopting you into a club, and they're guaranteeing that nobody in that club is going to distribute malware. So it's kind of contradictory to the whole concept of open source where anybody can write code. So I'm not sure how this is going to work, and we're going to see how this works. They're trying to make a free cryptographic software signing. Certainly, if the software you downloaded from open source libraries was properly signed, that would mean you could trust it not to contain malware and it hasn't been hacked if you can trust the author. But that's why it's not free. It would then cost money. So we're going to see what comes of this. I guess they're going to try to have some kind of open source free auditing to decide whether you're trustworthy or something like that. I don't understand how this is going to work. I'm very interested to see what comes of it. Anyway, the fastest supercomputer in the world is in China. A lot of them have been in China. Or is it China? Or Japan, pardon me. Yeah. And so anyway, it's up. They've been working on it for a while. They've got it up, and it has more ridiculous 7 million cores running on ARM, 64-bit, which is what I've heard a lot. That's where all the modern servers are going, and the modern desktops too. If you look at your iPhone and I think your Android phones and your new Mac. Everything's running on ARM these days. Intel is on the way out. That's what I've been hearing for the last several years. Anyway, so there is a market for these expensive encrypted phones. And one of them is Sky. You pay like $2,000 for a phone. It's real expensive. And I don't know why anybody would buy it except basically a drug dealer. You have to be some kind of criminal. I mean, in principle, you could buy it because you're just very worried about your privacy. But typically, the only people this worried about their privacy are criminals. So this company, Sky, that sells these phones, the cops got the data and they started arresting people, and they said the cops had hacked into the phones and decrypted their encryption. But Sky says that is not true. What happened is somebody stole imitation, knockoff Sky phones that have an inferior app which got hacked. And either of these is possible. And the cops have actually, in the past, in other countries anyway, they have actually sold fake phones that pretend to be encrypted when they aren't, to get drug dealers and stuff. So anyway, it's interesting to see. I know in Germany they hire security researchers specifically to write malware to give to the cops so the cops can use that malware to hack people as part of law enforcement investigations. Now in America, the NSA does it to our foreign adversaries all the time, but I'm not aware of American law enforcement being authorized to put malware on devices to track people in the country, although it might be happening. But in Europe, it's permitted more. Anyway, I'm also not aware of American law enforcement selling people fake devices to get their traffic, although we absolutely do it as the NSA to our opponents. And this one hit the news a while ago. There was a teacher who was beheaded, a school teacher beheaded for putting up an insulting picture of Mohammed or something. And then the person who beheaded him was killed or committed suicide or something. It was quite a big deal in France, and now it has come out that it was all a lie. The French schoolgirl spilled the beans about this and created an online sensation that caused a man to feel like this guy had insulted Mohammed and killed the teacher, and it turned out she was just lying. She wasn't even in school that day. She was in fact expelled for some form of bad behavior a few days before that, and then she lied to try to make herself into the hero and ended up getting this guy killed. So that is a serious problem. Kids often lie about things. So, you know, it's an issue. And I know there's a big issue now about Betsy DeVos's rules about due process for sexual assault accusations on campuses. And now the Biden team is trying to reverse that. But it is a really thorny problem when you get these accusations from children and they're not really backed up by independent evidence, like, you know, video camera footage or something. You don't want to ignore these crimes, but you can't really trust that evidence too much, and it just becomes very difficult to know what to do. Anyway, we're up to the official time here, so there are a whole lot of upcoming events in the coming week, having more or less related to the college. They're all worth extra credit. Irvin is doing a talk, the same guy that did the Wireshark Captured the Flag, is giving a talk on the OWASP Top 10 at Pacific Hackers. You might want to tune into that. Yes, so many kids lie without thinking about consequences. Yeah, that's the problem. I mean, kids have an active fantasy life, and they're also not really they aren't thinking like adults do about the consequences. So, yeah. Anyway, that happens on Saturday. On Monday, I highly recommend this one. At 4 p.m. at a strange time, they're going to have former spies talking about their cybersecurity activities. These are American spies, I think. So I'll be there, and I recommend you being there. Let's hear what these people have to say. You don't normally get to hear much about what spies do. Secrecy is their whole thing. And then a cyber talent mentoring program here. So I'm not exactly sure what it is. There's a little more information at this link, but it's some kind of program to help people get training in cybersecurity and jobs and such. So that's important. And then there's the 4th GrimCon, and my team and I will be doing a Windows internal Capture the Flag, which is based on the homework for the CNIT 126. But anyway, you go to any of these things, and they're worth extra credit, and I highly recommend them. Although this one you can pretty much duplicate by taking CNIT 126 at City College, but some people like it in the Capture the Flag format. Anyway, so here we are. It's 128 mobile devices today. And we're down to the last part of Chapter 7, attacking Android applications. So I got my slides here. Let's start with them. All right. So we've been through this stuff, and now we're going to talk about storage and logging and other vectors that are used to steal data and take over the phone. So storage and logging, we've done a little bit of this in the projects. If it is Android is basically a Unix or Linux type system. So the permissions are, if you do ls-l of any file, you will see this permission string. The first character is a minus for files and a D for directories. And then you have rwx, rwx, rwx. If there's a dash there, that permission is not permitted. If you see the letter, it is permitted. So this file has read and write permission for the owner, but not execute. Read for other people in the group, same group as the owner, and no permissions for anybody else. So that's what these 9 bits are, what determines the level of permission. All right, and the kind that you hear them talk about in the book quite a bit is when you have world readable, writable, and executable, referring to the last 3. If your file is world, read, writable, and executable, then anybody can change it, and then it's likely to be used as part of an attack. So you can make those numerical by using octal, where you take each 3 bits and the read part is 4, the write part is 2, the 1 part is execute is 1. So 7 means all these. So 777 is letting everybody have full control of this file. And that's very rare because that's very dangerous. Anybody can delete it or modify it. The more common is 755, which is what you get for an executable that you want everyone to be able to execute, but only the owner can change it. And 644 is something where people can read it, but it's not executable. Those are probably the more common permissions you'll see. Now there is in the operating system a quantity called the umask, and that is what determines what the default permissions are of a newly created object. And so, for modern versions of Android, the umask is 77, and the umask is, for some ungodly reason, the opposite of the permissions that will appear, just to give you a headache. So this means you don't get the 2 7s here. So the default 077 is the important part of this. So everything you create will have read, write, execute for the owner, but no permission for anybody else, which is, of course, another way of expressing the basic Android security model that we've been talking about all along, where each app has its own user account, and each app can only see its own data, and not the data owned by other apps, unless, of course, those apps have the same signature and they share a user account because they're all from the same company. And it does have traversal checking, which, by the way, is not always true on Windows systems, but it's always true on Linux systems as far as I know, where even if you make a file readable, that does not mean people can actually read it. The folder it's in must also be readable, and all the folders above it must allow them to read. The point of this is, if I have a folder and I have a bunch of files and folders in there, and I want to make that a private folder, all you have to do is change permissions on the containing folder. And that stops anybody from going inside that folder. That's the point. That's called traversal checking. And Linux does enforce traversal checking. This is an irritation for a lot of people. I know when I used to teach web design years ago, people had accounts on a Linux system, and you would go to the var www.html folder and create a file, hoping to see a web page, and then you couldn't see a web page because you had to change permissions on the file and on the folder containing it, and on the folders above it, and only when you got all those permissions changed could you see the file. But that's the way it ought to be if you want to have any real hope of securing it. So, DroidWall was an app that used the IP tables firewall. I've seen firewalls do this. I've seen antivirus programs do this. This is a fairly common trick. They want to allow you to adjust something, like the firewall settings, but that requires administrator permission. So they make a file someplace which runs with administrator privileges, which you're changing in their GUI where you're choosing things. So it's making a script which runs with 777 permissions, which is not a good idea. Now, you could make it a SUID file, so it runs as root, but it shouldn't have write permissions for everybody. This should have been probably 755 or something. And so you could add commands to that file from any app and then those things would be run as root later. And this is basically the heart of almost all privilege escalations. Last night I was demonstrating a brace condition. This is how you typically escalate to root. You find some process on the operating system that does escalate to root, and you find some way into tricking that into doing an extra command, and then you can escalate yourself to root. All right, so you can encrypt files to protect them from some attacks, although this is far more difficult than you might imagine. For example, if you encrypt the whole disk with something like BitLocker on a Windows system, that doesn't protect it from any malware type attacks or any attacks while it's running, because while it's running and logged in, the key is in RAM and you're decrypting the hard drive. So it's not, and even if the key is not in RAM, there still has an ability to read the files. So the only thing encrypting it does is protect data at rest when the machine is off. But anyway, you can encrypt a file to stop other people from reading it to some extent, but then you have a key somewhere. Unless you're using public key encryption, which is almost never done, you've got a key somewhere. And what a lot of people do is they just hard-code it into the source code. And we've seen this in some Android apps, passwords in the source code, and like the Safeway app, putting your key in a configuration file. So one thing people did in databases is they used a library called SQL Cipher, which lets you create a database, and you can put a password right there when you create a database, but the password is just sitting right there in the source code if you do it this way. Now, the better way to do it is you want to read it from some file, and that file ought to be protected by permissions. But anyway, that's one of the many variants of what we've been doing in quite a few of the projects here, where people use private key encryption and then they try to hide the key on the phone, which is pretty weak. And so there's a cracker. This is a simple one-liner bash script that will go through and pull all the strings out of the apps file and then try all of those as the password. It'll feed them in where the star is and put them here. So anyway, it'll put this every one of those words in the source code, it'll put it in this variable called pass, and then it will just try to decrypt it with every one of those. So if they did leave the key anywhere in the source code, you'll find it this way. That's a fairly common trick in the world of computer forensics too. Another thing you often do is if something is encrypted on a hard drive and you're investigating a hard drive full of evidence of some sort of crime, then you take every string on the hard drive, make a dictionary, and try all those as the password, because people often save the password somewhere in a Word document or text file, and if it's anywhere on the drive, you'll get in that way. All right, now the SD card is a little floppy looking thing that you can remove from your phone, and those things are typically very insecure, just like floppies, and most USB sticks, they're typically formatted with FAT32, which is the really old way of formatting a disk dating from the 90s when nobody thought about security much. So there were no permissions possible. There's no owners of files. There's no read, write, execute. There's none of that stuff. If it's on the floppy, everybody who has physical possession of that device can read and write it. And the same thing's true of SD cards. So if your app does put data on there, it's exposed to a lot of people. It's anybody with physical access to the phone, among other things. Now, in the early versions, they required no permissions to read, but you had to have permission to write to the card. Before Android versions before 4.4, but later on, they enforce that you must have this read permission to read the card, and then they made it so that you cannot get that permission. I'm mixing up something else. Anyway, that's the point. There is a read permission. The point of this is when you first install the app, a box will pop up saying, this app has to access your network card and such. It'll say access the SD card. So at least the user is informed. Now, this is a really weak security boundary because most people don't read those permissions or care. They just click whatever to install the app. So in a way, that doesn't really provide security. That just provides something like legal liability, like those terms of service. So you can say, well, we told you it was putting data on the SD card, and you were, but anyway, at least the technically savvy and careful users of their phone will know that it's putting data on the SD card, although I bet most people won't even know what that means. Anyway, WhatsApp stored its database there, so anybody could read it. It was encrypted, but with a static key, which somebody found and just wrote a tool you could download to open it. So it's another one of these many, many apps that hide things on the phone with private key encryption, but the key is somewhere where you can find it. So anyway, data put on the SD card certainly shouldn't be trusted to be secret unless you encrypt it with some good form of encryption where people can't find the key, which is not simple. If you're going to save anything securely, you should really be putting it in the Android keychain. Or better yet, figuring out how not to save anything secret on the phone at all. You usually haven't really thought it through if your design process leads you to the conclusion that I have to store a secret on the phone. You probably don't. Anyway, then there's logging. Now logging is there so you can record what's happening in your app, and then you might be able to help debug it. It is a best practice to turn off all logging in your app before you run it. And if you use these security scanners on apps, it'll warn you if logging is turned on at all. By the way, a student said before class, at the start of class, that QARK is not installing correctly on the latest version of Kali. So if you're trying to do that project and having trouble, then just put it off. I'll check it in the coming days and see if I can figure out what to do with that project. Probably, I'm just going to get rid of Kali. There's really no need for Kali in this class. I'm thinking my plan is to just move to straight up Debian for more and more of the projects, and I'll probably just figure out how to install it on Debian. But anyway, all right, so any application with read log permissions can read the logs. That was the idea. But in Android 4.1, they changed it so that this has got the development and system permissions, signature or system or development. And what that means is you cannot request the, yeah, that's good. Okay. It means you cannot request this permission and have a box pop up and say, this app wants to read the logs. You're not allowed to. Nobody can do that but Google, which is a pretty good idea. Of course, you can do it on a rooted phone. If you have a root shell with the project management command, you can give read logs permission, but of course, that is not really a security flaw, because if you have root on the phone, then their security model is shot anyway. Which project am I talking? There is a Quark project. So if you go here, there are, I think, 2 or 3 projects where you use vulnerability scanners. This Quark project, people tell me, is not working because there's a new version of Kali and they always break everything. Yeah, 302 Androbugs isn't working either. Okay, fair enough. I use Debian 10, right? Yeah, thanks. That's what I figured. I'm probably just going to tell them. Yeah, probably just going to tell people to use Debian and forget about Kali. I used to teach the pen testing classes, and we used Kali for everything, so my students had it and I was used to it. But I'm getting about fed up with Kali. A lot of people are. We should just use plain old Debian. We'll have a lot less trouble for what we're doing in this class. Anyway. If you're trying to do these and you can't do them, they aren't due yet, are they? That would be annoying. Let's see. 128. Schedule. This is March 10. And, oh, they're due. Okay, I'll change these due dates then. Well, that's no good then. Okay, thank you for telling me. I'll move these due dates out a couple weeks then because the projects are not working. Make them later. Extend deadline. So sorry about that. All right. It's a shame when I have things due and you can't reasonably do it. So I'll move this out at least another couple weeks. All right. Good. All right. So then there's insecure communications of various types. Now you might send data unencrypted to the internet with HTTP, like several of the apps we've looked at in the projects. You might send HTTPS without validating certificates, so you can do man-in-the-middle attacks with burp or other techniques, and those are examples of insecure communication. Yeah, I wouldn't bother using any old version of anything. I'll just switch to Debian. Kali keeps breaking everything. Kali updates like 2 or 4 times a year, and they're very sloppy about updates, and they break everything. So it's and you don't want to use an old version of Kali. I mean, you can, but the Kali doesn't support anything but the latest version. So Kali is too irritating. I think just using mainline Debian would be a lot better. Anyway, so if you have insecure communications, if you have if a developer has not implemented certificate checking, then you can run burp, and it will, like GDMD, will let you do so-called HTTPS through burp. It'll believe the false certificate, so it's encrypted, but it's encrypted with the wrong key, and burp can open it, and you can see the name and password go by. So even though this claims to be HTTPS, it's not really secure, because they didn't really go through all the verification steps required for secure communications. And now some apps fail to check the certificate at all. Some do ordinary HTTPS, where you just have to have a real certificate. And certificate pinning is another layer of security where the app has another number, so it will recognize whether the certificate is the official certificate or not. So even if you had another certificate from a trusted certificate authority, it won't accept it. All right, and I see Quark requires Python 2. Yeah, all right. Yeah, that's why I might just eliminate Quark, or I'll see what I can do. Yeah, good. I'm glad to see these comments to help people who are trying to solve it. Anyway, so if you want to get past certificate pinning, there are ways to do it. You can try adding a custom certificate to the Trusted Certificate Store. That's one way. Sometimes that will work, but it won't work if you have certificate pinning, because it won't accept a different certificate authority. It has an internal record in the app of who the certificate authority should be. You can try overriding a certificate. You can use Frida, which is an app that lets you change parameters in the operating system to try to bypass SSL certificate checks. And the other way, which we're using in the projects here, is the strongest but most difficult technique, where you modify the app, changing the code to remove that. And that's what we're going to do in the project. So people often, there are very easy ways for developers to turn off certificate pinning, so they can just turn off certificate verification, so they can test the app. They can add a couple of fake methods here, which will override the methods normally used to verify the certificate. And then that would make a test version of the app that's easier to test. But you would need to remember to remove that before deploying the app. And obviously, a lot of them don't remember that. All right. So that's, anyway. And I thought I'd have this. All right, I guess we'll get to it later. Somewhere there's a project where we take that away. We overcome this stuff in one of the projects. Anyway, all right. Now, Webview is a little browser function, a library you can add to your app so you can open a web page in your app. And this is something that a lot of apps do. If you want to have something that says, go to our web page and sign up for something, then you could open the default browser. But if you did that, it would leave the app, open the browser, and be over here. And then they wouldn't come back to your app, so you'd lose the customer. And they wouldn't have your brand name at the top and all that. So that's not very desirable for developers. So what they prefer is to have a little browser inside the app, where you have a frame around it, you're still inside the app. So they run WebKit or Chromium inside the app. And now your app includes its own web browser, which makes it prettier. But it also means that if you do it wrong, you expose data, even data that's not related to your app. And when I went to the West Point app and the Air Force Training Academy app, they all did this, and they used a broken browser that broke HTTPS. So you would lose not only your credentials for West Point, you would also lose your Twitter and Facebook and Google credentials if you click the social media links inside the app and it used the included browser to connect to those sites with broken HTTPS. Anyway, all right, so you can control the settings of Webview in the web settings class. You can give this local browser library, you can give the ability to do dangerous things. So you can let it have access to content providers on the system, so the local browser can access stored data in databases. You can let it load files from the file system using the file scheme. You can allow those files to access other files on the system. It is getting more and more crazy dangerous. You can allow it to get files from any origin. You can allow it to execute JavaScript, and you can allow it to load plugins like Flash inside the Webview, inside the app. And of course, the more of these things you turn on, the more security risks you're taking. Unless you really know how to secure all these features, you're probably going to open a door for someone to do something. And then you can make it so you can save passwords in the app, in the Webview, in the app. So, turning on all these things takes on a really large security responsibility, which your normal app developer probably doesn't really have the ability to properly handle. Anyways, that's Webview. And by the way, it might load content over without encrypting it. Then you can easily pick it up in the middle. And if you do, you can then send a malicious intent with an extra containing a file, and if they've allowed you to refer to local files, you can load some other file and run some JavaScript in it and attack the phone that way. So, you know, if you leave those things on. And if you think that's dangerous, this is even more dangerous. JavaScript interfaces. This is basically command injection built into the app. This takes JavaScript within Webview and connects it to Java so it can execute Java code. So you define it with a JavaScript interface. Now you create a string that will just say hello, but this is running Java, and you can call it from JavaScript down here. So you call this Java R hello from inside JavaScript, and that will reach the JavaScript interface named Java R someplace, and it'll run this. So anyway, all right. Car worked on latest Kali. All right. I'm going to record this one. Somebody has a clue how to make Quark work. This might be good enough. I'll save that information and see if I can use that to fix it. That's good. All right. Anyway, so this JavaScript interface vulnerability is so serious that apparently any app that targets an older version of Android, less than 4.1, has a vulnerability where you can execute any OS command. So this is interesting, and I haven't tried this. It shouldn't be too hard to find an app like this. All I have to do is find one of the apps, like probably some of the ones we're using in projects. Any app that hasn't been updated in maybe 5 years would fit this requirement, and that would mean we'd be able to run arbitrary code. So this is pretty interesting, tempting to be a project. I haven't seen this really go, but we should be able to make a project out of that. Several things in this part of the chapter are sort of begging to be projects, and I might develop them. I'm just busy doing other things at the moment. Anyway, there's a Drozer module just for this JavaScript bridge that will check to see if you have vulnerable JavaScript bridges, and this one will tell you. This one targets the old SDK version 15 and therefore is vulnerable to that. So it should mean any app that uses WebKit and targets an old version of Android, you should be able to run arbitrary code. So that will be interesting. All right, and here's other fun things. You have a clipboard on your Android phone, just like on other operating systems, and the whole point of the clipboard is you can copy data and paste it into another app. So that means by definition, every app has read and write permission to the clipboard. So if you have a password manager that uses the clipboard, it's very insecure. And when I was reading the book again today, it said, you know, every time you put something in the clipboard, that creates an event, and every app can listen to that event. So they pick up data as soon as it goes in a clipboard. Even if you made a password manager to put it in the clipboard and tried to delete it later, that wouldn't mean you couldn't sniff it. So there's a Drozer module to capture what goes in a clipboard, and you'll see passwords. So now, I don't understand how a secure password manager would work. It apparently can't use the clipboard. So I don't really understand how your password manager app can move the data into the other thing to log in. I don't think I've used any password managers on a phone, so I'd be interested to know what they do. Apparently, they're not using a clipboard. If they are, that doesn't seem safe at all. There must be some other way to move data from one app to another. Don't really know what they'd use. Anyway, OAuth would be an answer, but the app would have to cooperate with that. Another thing you can do is, and this is true on Windows machines and all over the place, you have these local ports listening on the loopback address on often a high-numbered port number. So this is, you can open a TCP listener on the local address. So it's listening for network traffic, but only from the same device, not real network traffic traveling over, you know, the Wi-Fi or anything. And now any app can send and receive network traffic there. So you can make a communication channel to go from one app to the other through the networking or just through raw Unix sockets here. But if you do, you have bypassed all the Android security model, and it's up to you to now try to make sure that some other app that you didn't plan on isn't putting data there, and the data doesn't include dangerous characters and code injection and everything else. So that's a possible way to write an app, but again, if you do this, you take on yourself a large security responsibility as you open up another door. And so you can expect, if you do send traffic to the internet, of course, as we've been doing in the projects, you can expect that with a lot of techniques like Wireshark or Burp or the command line TCP dump that does the same thing Wireshark does, but from the command line. And then you can pick up the traffic going to the internet and check it to see what protocol it is and whether it's encrypted or not, and things like that. And there are other ways to attack apps. There might be some native code in the app. Now, most of the code we've been talking about, and all the code we've been manipulating, is Java code that is compiled to Smalley bytecode, so it's still pretty readable and easy to change. But there is some code in there that's actually written with native, real languages like C and C++ that really compile right down to assembly code. So if you do, you can't open that stuff. Let's see, this got extra high in it. You can't open that stuff with just a plain text editor the way we're doing it. You're going to need like IDA Pro, a disassembler, or a debugger to analyze it, which we're doing in CNIT 126. And then it can have all the usual vulnerabilities like buffer overflows and such. And then you can develop exploits with a debugger. So this is what we're covering in the malware analysis and exploit development classes. All right. And then you can look for package attributes that are dangerous. For example, allowing backups. This is true by default. Of course, you should be able to back up your app to someplace like the cloud so you can recover your data if you lose your phone. But that means if I can get your phone and I can get past your password, I can just back up the app and get all the data that you stored in the app. So that's pretty obvious. Okay. And then there's the debuggable flag, which is false by default. And again, I don't have a hands-on project for this, but I would really like to. So if I get the time, there's another part of this chapter I'd really like to make a project. You can turn on a debugger inside the Android app, and then it has a Unix socket JDWP control, so it's listening for internal traffic, and then you can run a Android debugger of some sort, which I've not used. You can get it over the USB debugging, and then you can run debugging commands. So this vulnerable Civ app that we've already used in projects is also vulnerable to this. It's got debugging turned on, so you can run it with the debugger running, and then you can dump out the data and see what it's doing. So that seems like a great thing to do, and I'd like to make a hands-on project out of it. But it's not in this class yet. All right, and here's some more fun things. Like I said, this is the one I thought I would see earlier. If you have certificate pinning, then that means the app checks the TLS certificate, that it is trusted from a real certificate authority, and then it also tests some other test. Additional information built into the app that tells you when this should work. And I see just something's working right. That thing, good. There's a recommendation of how to fix Quark, which I'll try. And then, of course, there's root detection. You might run something like root beer to tell if your app is on a rooted device, and that's in the projects. There's a device here that detects that your emulator is rooted, and all you have to do is go find the root beer code and comment it out and recompile the app, and then it will run. You can make a modified version of the app that's no longer got the root detection. And you can, in principle, do the same thing with certificate pinning if you can find the code that enforces certificate pinning. All right, and you can modify your Android. Into the Android system, you can put hooks in there so that when the app calls API functions, it gets Trojaned API functions. This is what rootkits do on Windows machines, and you can do it with tools, low-level hooks that go in here. You can do it with Frida and other tools, and this will let you change the functionality of the operating system underneath the app. So tools that do that are Cydia Substrate, Exposed, and Frida. And Cydia Substrate is what underlies a lot of jailbreaks. All right, anyway, let's try the Cahoots, which I've got here. (7C), that was the right one. Okay, good. I see. Apparently just skipping one step will make Quark work on the latest Kali. Well, I'll try that right after these cahoots. Well, looks like this might be everybody. All right. All right. What command makes the permissions like that? There you go. A lot of people know your Unix. Read is 4 and write is 2. So this is 6 and those are 4. So that's 644. All right. All right. What data was widely available but then restricted only to Google apps in Android 4.1? That's the logs. All right. All right. And what feature is risky but used by password managers? That's Clipboard. All right, and what component may allow code execution by JavaScript? Okay, that's Webviews. All right. Land off. And Peter. All right. Good.